Hello everyone, welcome all to Physics with Astronautics. So in this video, we will discuss about the previous year question of CPT 2024 and yeah, obviously the physics question. So let's begin. And here's our first question, that is the number of terms in the Legendre polynomial P37x each. And here are our options. So we know the general form of the Legendre polynomial, that is Pnx equals summation over k equals 0 to n by 2 akx n minus 2k. So here it has been given that n equals 37. Okay. So for n equals 37, so k will be from 0 to 37 by 2, that is 18, and so the total number of term will be 19 here, and the option A, that is 19, is the correct answer. Then, according to Bohr's theory of hydrogen atom, the energy difference between two adjacent energy levels, and the options are increase as one moves to higher energy states, decrease as one moves to higher energy states, remains the same for all the states, and is proportional to the difference between the principal quantum numbers of the two states. So let's begin doing the solution. Like हमको पता है कि जो बोर एनर्जी होता है वो प्रोपोर्शनल होता है 1/n². I mean for hydrogen atom. For any other atom, it is proportional to z²/n². Okay. So here it has been given that it's for hydrogen atom, so we can consider it as proportional to 1/n², and so our U1 will be minus 13.6 by 1 square, that is equal to minus 13.6 electron volt. Uh, like this, E2 will be minus 13.6 by 2 square, that is minus 3.4 electron volt, and so on. E3 equals minus 1.51 electron volt. As we see the difference between these consecutive states, that is E1 and E2, delta E12 will be minus 10.2 electron volt, and delta E23 is minus 1.89 electron volt. और हमें यहाँ पे दिख रहा है कि as we are moving higher and higher energy states, the क्या बोलते हैं, the difference is decreases. Okay, so here the option B, that is decrease as one moves to the higher energy state, is the correct answer. Let's come to the third question, that is which of the following is true for a transistor amplifier in the CV configuration, and here CV mentioned to the common base configuration. So हमारे पास एक ट्रांजिस्टर है जो कि है उसका जो बेस है वो कॉमन है with the emitter and the collector. Okay, so here the first option says that the output resistance is very small, that is the wrong one. The input resistance is very large, also this is wrong. The phase difference between the input voltage and the output voltage is pi by 2. This is not correct, because in CB configuration the phase difference is basically 0. Okay, then option D, the input voltage and the output voltage are in same phase. Okay, so the option D is the correct option. Like we know that in the CV configuration there is common base configuration. The input is applied at the emitter and the output is taken at the collector with the base common, and there is no phase inversion in input and output. So the additional information we can get here is the phase shift between input and the output uh, voltage, that is in different kind of configuration in the transistor, that is in common emitter this is pi, for common collector this is 0, again for common base this is 0. Okay, then an ideal coaxial optical system is in air. Which of the following is true? And here the options are: the principal points coincide with the focal points, the nodal planes are coincident with the focal planes, the distance between the nodal point is equal to the distance between the principal point, and option D says the distance between the focal point is equal to the distance between the nodal points. And here the option C is the correct one. Then an isolated homogeneous solid sphere rotates with a constant angular speed. Uh, I think okay, this should be conserved angular speed. Okay, like whatever. It's a constant angular speed. I think this should be constant angular momentum. Okay, but a fixed axis passing through its center. Suppose the sphere shrink so that its diameter reduces to half of its initial value. The rotational kinetic energy of the sphere is. So if you will take it as the constant angular speed, then this should be becomes 1/4 time the initial value. But if we will consider it as the conserved angular momentum, then say what will be the answer. So rotational kinetic energy for sphere is half I omega square, or we know. Then here I is the moment of inertia and omega is the angular velocity obviously. And also we know that the angular momentum L is equals I omega. And the moment of inertia of the solid sphere is 5 by 2 mr square. Here r is the radius, and so we can take it as d by 2, that is diameter by 2. So 5 by 2 m d by 2 whole square. So for the rotational kinetic energy of the sphere is half I omega square. By putting all this value here, we can get it as 5 by 16 m d square omega square. But what happened? When the sphere shrinks so that its diameter reduced to half of its initial value, तो क्या हुआ? वो sphere ऐसे मतलब shrink कर रहा है जिससे कि उसका diameter जो है वो reduce कर रहा है half of its initial value. Okay, so here what happened? I dash is become 5 by 2 of m and d by 2 का 2. Okay, so d by 4 whole square, and again if the angular momentum is conserved, then I omega will be equal to I dash omega dash, and your omega dash is equals, by calculating all this value, like putting all this value here, we can get it as 4 omega. So omega dash equals 4 omega, and now the final rotational kinetic energy of the sphere will become half I dash omega dash square, that is equal to 5 by 4 m d square omega square. So initially it was 5 by 16 m d square omega square, and later it become 5 by 4 m d square omega square. So from these two equations we can get that I dash by I equals this, and here I dash equals 4I, that is 4 times the initial value. Okay, then in the binomial expansion of 3 plus 2x to the power 50 with x equals 1 by 5, the largest term is the, तो जब हम इसको expand करेंगे तो एक term आएगा फर्स्ट सेकंड थर्ड फोर्थ करके, तो वो कौन सी term होगी जिसकी वैल्यू सबसे ज़्यादा होगी. Okay, so here the options are 25th, 24th, 6th and 8th. So let's read the solution. In general, we know that a plus b का whole to the power n equals summation over r equals 0 to n. This is NCR, a n minus r b r. Here a is the first term and b is the second one. Okay, like this and this. Then in general term, r plus 1 is the expansion of a plus b, and like t r plus 1 equals NCR a n minus r b to the power r. So in 3 plus 2 x whole to the power 50, like we have given that x equals 1 by 5. So by putting the value x equals 1 by 5, we can get it as 3 plus 2 by 5 whole to the power 50. And so here the t r plus 1 term will be equal to 50 cr 3 to the power 50 minus r, and 2 by 5 to the power r. Again, the maximum value terms occurs when the ratio t r plus 1 by t r will be less than or equals to 1. Okay, so by putting the values here, the expression here, we can get expression, the final expression, that is 2 into 21 minus r whole divided by 15r. If we will equate it to 1, we can get like 102 equals 17r, and so r will be equal to 6. Okay, as we know that the like when r equals 0, this is first term. Okay, so for r equals 6, this would be seventh term, but in our options we don't have seventh term, so maybe it can be sixth term according to the options, but this could be seventh term. Then in a propagating electromagnetic wave, the dimension of the Poynting vector is the same as the dimension of the options energy, energy per unit time, power per unit time, and power per unit area. So here the option D, that is power per unit area, is the correct one. Then in the vibration of a diatomic linear chain of atoms, the optical mode corresponds to. Here you can see the options, and in the vibration of the diatomic linear chain, like in a linear chain, diatomic means one atom has the mass m and the second one has the mass m2. Okay, like m1 and m2, two different mass. So the motion of the two types of atoms opposite to each other, with the lighter atoms having greater amplitude. So this is the correct option. You can see the other options too. Then, in a real gas, with the van der Waals constant A and B, the boil temperature is. So first we should know what is boil temperature. Okay, so the temperature after which real gas starts showing the properties of an ideal gas. एक ऐसा टेम्परेचर होगा जिसके बाद की जो हमारे पास जो रियल गैस है वो आइडियल गैस की तरफ परफॉर्म करेगा, तो उसको हम बेसिकली बोलते हैं बॉयल्स टेम्परेचर. ओके, so for 1 mole of van der Waals gas, like we know the van der Waals equation, like P plus A by B square, V minus P equals RT. Okay, so for n mole we know that P plus A n square by B square, B minus NB equals nRT. So we are taking it as 1 mole. So we have to write this equation, and from here हमने P को कॉमन लिया, so that this could be 1 plus A by B square, एंड हमने यहाँ से b को कॉमन लिया, सो ये हो गया 1 माइनस बी बाई बी का बी बाई बी. ओके, इक्वल्स आर टी. तो हमने यहाँ पे क्या करा, पी भी को एक साथ ले लिया, दिस को जैसे था वैसा रख दिया, यहाँ पे आर टी है. सो पी वी बाई आर टी इक्वल्स, अगर हम इसको यहाँ इस साइड ले जाएंगे तो क्या होगा, टू द पावर -1. और उसके बाद हमने सॉल्व कर लिया, लाइक 1 plus x to the power n equals 1 plus nx plus n into n plus 1 by 2 फैक्टोरियल, ऐसे करके. तो यहाँ से हमें मिला कि पी वी बाई आर टी इक्वल्स 1 माइनस ए बाई बी वी स्क्वायर एंड 1 प्लस बी बाई बी. ओके, so by solving this we can neglect this term ab by bb cube. Okay, because this is very small, and later we will get pv by rt equals 1 plus b by v minus a by pv square. अगेन हमें क्या पता है, बॉयल्स टेम्परेचर वो होता है जहाँ पर रियल गैस आइडियल गैस की तरह परफॉर्म करता है. ओके, लाइक उसकी प्रॉपर्टी जो होती है वो आइडियल गैस से मैच करती है. अगेन वी नो दैट इन आइडियल गैस, ओके, बट 1 मोल वी नो पी वी इक्वल्स आर टी. तो हम जब इस इक्वेशन को इस इक्वेशन के साथ कंपेयर करेंगे, सो पी वी इक्वल्स आर टी लाने के लिए हमें बी बाई वी माइनस ए बाई पी वी स्क्वायर इक्वल्स 0 करना पड़ेगा. सो वी आर डूइंग सो b by v minus a by pv square equals 0. So from here we are getting that b equals a by pv. Again we know that pv equals rt in case of ideal gas for 1 mole. Okay, so in case of pv we are putting it here rt, that is a by rt equals b. So from here we are getting that t equals a by rb. So here the option A, that is the Boyle's temperature equals a by br, is the correct option. Then in the Compton scattering of photons by electrons, the Compton set of a wavelength is equal to the Compton wavelength of the electron when the scattering angle theta is equal to. तो हमें बेसिकली यहाँ पे थीटा फाइंड आउट करनी है. ओके, तो Compton स्कैटरिंग में क्या होता है हमें पता है, जो delta lambda, this is the shaped in the wavelength. Okay, lambda dash minus lambda equals h by mec 1 minus cos theta. Okay, here lambda dash is the scattered photon wavelength and lambda is the incident photon wavelength and theta is the scattering angle of the photon. और हमें given क्या है, the Compton shape of the wavelength is equal to the Compton wavelength of the electron, that is h by mec 1 minus cos theta. This is equal to h by mec, that is this is the wavelength of the electron only. तो हम जब इसको solve करेंगे we will get that theta equals pi by 2. That is the option C, pi by 2 is the correct option here. I hope you enjoyed this session. So for more videos like we have solved here from question 1 to 10, like हमारे पास अभी बच्चा है 11 to 70, नहीं 11 to 80. Okay, so उसको solve करने के लिए if you are liking my videos, please do like, share and subscribe. Thank you.